All right, Math 7 today we are going to review our Chapter 1, Coordinates and Design. But more importantly, about three types of transformations. So, right after this review, you will receive a assignment. An assignment involves worksheet. And you need to perform some kind of transformation like translation, reflection, or rotation, or everything. But it's gonna be one at a time. It's not gonna be the combination of transition and reflection. Nothing like that will occur. All right, so before we getting into each of the type, it is good idea to understand a summary of these three different types of transformation. First thing first, known as translation. Translation is kind of like sliding. Your image is slide to one side to another side. Number two, reflection is like mirror image. Whatever you see on the left side is now will be located on the right side. And imagine a mirror image. Like if you raise your left arm, then the mirror yourself is actually raising your right arm. So there is a little bit of how can I say? We call this superimpose. It's not superimposable. That means I cannot overlap. Like for example, my right hand and my left hand, those are a little different because it's a mirror image. They are not exact same type. And number three, rotation. Rotation image is basically a angle type. Like what I mean by that as an angle is 90-degree rotation, clockwise, counterclockwise, those kind of situation. So simply rotate it with angle is what I want to point it out. These three types, although they're using different type of movement to generate the new image, there are a few things that you need to have it in your mind. Number one, size does not change. Size is basically identical. And number two, quadrant of original image will, or actually will is such a strong word, may change, especially if it's reflection or rotation. There is high possibility. Now, without further ado, let's do some classic example. Example number one. I'm going to do an example of transition. If you have a graph paper, that is awesome. If you don't have a graph paper, you guys remember 10 centimeter, 10 centimeter, up and down. I'm gonna use a better one over here. And you will hand in your assignment in either blank pieces of paper or graph paper, something like that. There we go. X, Y. This is a basic setup, ladies and gentlemen. This is a basic setup. In fact, why it's a good idea to be placed over here. Let's create an original image. And by the way, it is good idea to identify what type of quadrants that original image belong to. And at the same time, it's good idea to identify the coordinate of each of the systems. So let's do, I always like triangle because that's easy enough. I should have used my ruler. Sorry folks, it's become suddenly ugly. A, B, C. A, B, C. A, I'm gonna put, actually it's 2, sorry. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So according to this system, it's 2 and 1, 2, 3, 4, 5. 2 and 5. 1, 2, 3, 4. 4 and 2. And C. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5. 7 and 5. Always remember, your first location is X coordinate position and Y coordinate position. And you know that this is quadrant 1. So I have triangle like that. Now, every transformation, including this first type transition, you will have some kind of condition. You will have a condition in terms of move an image 4 to the left, and 2 down, something like that. Then what you need to do is basically you're doing bunny hop method or you're moving one by one. I call a bunny hop method because literally I need to bunny hop 4 to the left and 2 to the down. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. My new A's location is over here. I'm gonna put A prime. B, 1, 2, 3, 4 to the left, 1, 2 to the down. Oh, it turned out to be origin over here. B prime. And C, 1, 2, 3, 4, 1, 2. Located over here. There you go. So that is my new image. My new image, don't just put the answer like this. It's a good idea to find out what's my new coordinate. A prime is 2 to the left, 1, 2, 3 to the up, so negative 2 and 3. B's turned out to be at origin. I didn't plan to, but it happened in that way. C is located at where we are at 1, 2, 3 to the right, 3 to the up, so 3, 3. I want you to put answer in this way. Always not only draw the final product, it's good idea to put an actual. And when I say an actual, it has to be very solid coordinate system in addition to my drawing. So I want you to put drawing, final image, and the coordinate. And lastly, tell me what quadrant this image is located at. It actually have 2 quadrants. I can say quadrant 2 and quadrant 3. Oh, sorry, quadrant 1. Because it's counterclockwise that is going. Like 1 is over here, 2, 3, 4. So right now, my image is located at quadrant 1 and 2. Transition is easiest because you're basically sliding an image, you're doing bunny hop to locate it into new image. Now next one, let's do a reflection. Now reflection has few different ways. The very first thing of reflection that you can do is, what if it's reflect about x-axis? That means my x-axis is the one that become a reflecting line, so you're basically folding top and the bottom. Think it in that way, like origami in fine arts. Or number 2, reflect about y-axis. So that's other way around. Y-axis is the vertical line. So imagine I have an image over here on the left side. Then it's going to locate it on the right side because it's folded as a vertical point. Sorry, vertical line, which is y-axis. Third possibility is x value is equal to something. Fourth is when y value is equal to something. Note the fact that when x is equal to something, dotted line of reflection, is located on x position. If it's y is equal to something, same thing. Line of reflection is located at certain y situation. So I'm going to do a quick example with you. Again, 5 centimeter, 5 centimeter. 10 centimeter. And then at location 5, another 10 centimeter. This is one of the reasons why, like I mentioned, graph paper works the best because it makes your life easier, but not entirely necessary. If you don't have, you don't need to shop. Just be specific. Now let's do triangle again. A, B, C. This time I want to make it pretty. There you go. Now, this is, of course, quadrant 1. A location, B location, C location. You need to indicate that. So that's 1, 2, 3, 1, 2, 3, 4, 5, 3, comma 5. B is 1, 2 to the right, 2 to the up, 2, 2, 3, 4, 5. C is 5, 1, 2, 3, 4, 5. No, 6, sorry. 6 to the right, 2 to the up, so 6, comma 2. Now let's say this original image is, now its condition, reflected about x is equal to -1. So, as you may notice, folding through x-axis and y-axis, it's easy because it's like if it's about y-axis, you just need to flip it like that and that image will be located over here. If it's about x-axis, it's up to down. But now the condition is a little tricky. X to the power x is equal to -1. That means my reflection line has to be indicated by u. Can you see I'm putting this very poor dotted line, sorry, but that's my reflection line or line of reflection. Doesn't really matter. After that, what I need to do is count the distance and redraw, right? So what does that mean? That means I have 1, 2, 3 away from this. So opposite way, 1, 2, 3. That's where my new image should be located at, B prime. I have a 1, 2, 3, 4 distance away. So I need to go 1, 2, 3, 4. To the left in this case. C, same thing. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So long story short, if I connect all of these guys together, here is my image. It is exactly identical shape. Some people may say it doesn't look like same, but here's the thing, it's exactly same. If you look at, like, I have this three squares between A and B, and when it comes to these, like 9 square, you can count it too. But long story short, that's what it is. This is located at quadrant 2. Like I said, reflection generally move entire quadrant to another quadrant, and my final answer is basically finding out the new coordinates, right? So A is 1, 2, 3, 4, 5 to the left, -5, 1, 2, 3, 4, 5, -5 and 5. B is 1, 2, 3, 4, -4 and 2. C is 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, -8 and 2. There you go. That's my type number 2, reflection. Now my last, ladies and gent, type number 3, example number 3, if you will. That involves our rotation. when it comes to rotation, few things are required. Angle and direction. Angle and direction. So what I mean by that is, angle, actually it's a three things, sorry. Point of rotation. Direction, there are two. First thing first, clockwise or counterclockwise. When it comes to the angle, there are 90-degree option, 180-degree option, and 270-degree option. 360-degree is technically useless in that case because it's going back to its original position. So, without further ado, why don't we draw Cartesian plane and do a quick example. There you go. This time, why not? We're doing. I just purposely did it. Location is quadrant number 2. And let's say we're doing coordinate first, sorry, B, C. Let's say A is located at 1, 2, 3 to the left. 1, 2, 3, 4, 5 up. So negative 3 and 5. 4, 5. B is negative 5 and up by 2. Negative 5 and 2. And then it's negative 3 to the left and then 2 to the up. Negative 3 and 2. Now, let's say my point of rotation is at, so I'm gonna put P at why not negative 1 and negative, let's actually make it easy enough. What about negative 2 and 0? It's like easy but challenging just a little bit, because I found that when it comes to 0, some people get confused because that means it's along the axis. In this case, negative 2 and 0 means it's located over here, point of location, rotation. Now, why don't we do 270 degree, and I can easily say clockwise. Now, 270 degree clockwise means I need to move this and rotate 1, 2, and 3. But if you actually think about it, 270 degree counterclockwise is the exact same as 90 degree counterclockwise. This is where spatial ability is required too. And although the textbook says use a tracing paper, I know not a lot of people have a tracing paper, so that's why I'm using this ruler. I'm personally really bad at rotation just because my eyes are bad most of the time. 90 degree counterclockwise, so you may notice that my finger is at point of rotation, and then I have my point C because it's the closest. I like to do whatever closest to that, and I'm gonna rotate just once, and it's located over here. So that's my new location C. Same thing I need to do. Point of rotation over here, and then rotate just once. Sorry, I have a lot of obstacles, so I'm going to rotate. There's a laptop that hit me, and then yeah, I cannot rotate this. So if you don't mind, I'm just gonna go off the screen a little bit just in order to rotate, okay? once I draw, B and C are on the same line, which makes sense. As you may see, B and C is along the same line too. And A, which similar scale, I'm gonna rotate. Sorry folks, again, spatial issue. But you guys got the idea. Locate that dot at the corner, put your finger at the rotation point, and rotate and then see where the line exists. So I'm gonna do that. Sorry, it took some time, but A's new location is along the line C over here. So here's my rotated image. Again, size didn't change. Your quadrant, however, changed. Quadrant is now located at quadrant 3. Now my new location of it, A, B, and C. A is 1, 2, 3, 4, 5, 6, 7. So to the left and 1 to the down. So -7 and -1. B is 1, 2, 3, 4 to the left and 1, 2, 3 to the down. So -3. C is located 1, 2, 3, 4 to the left and 1 to the down. That's my final answer for both situation. Again, make sure when it comes to my conclusion, always know the relationship between 90 degree and 270 degree. Unfortunately, when it comes to 180 degree, call it unfortunate or fortunate, counterclockwise versus clockwise, it actually will have a same result because I'm moving it to once, twice, either clockwise in this situation, it's located in quadrant 3, right? You can do the same thing, 1, 2, it's located on quadrant number 3. If it's 180 degree situation. So that is my review lesson for today. I want you to go to Google Class and then click the assignment that I posted. There will be 2 different type of assignment. One for Math 7A class as a title, one for Math 7B as a title. I will put who's Math 7A, who's Math 7B if you don't recall, but you should do your own class worksheet. It is slightly different. And there will be handing in due time and date. It will be on the same date, just the time that you need to worry about, but there's 2 ways you can hand in. One way is if you can take pictures using your cell phone and all, doesn't really matter. Upload those pictures in Google Slide. You guys have an experience with Google Slides. Each of the picture at each slide, then hand in to Google Class. That's a one method. When it comes to number 2 method, you can, if you have a printer scanner, scan your assignment and just upload to Google Class. You can use, generally if it's scanning situation, it will be PDF file. If you have a hard time, please ask your parents for how to upload those situation. Okay? Thank you.